Now the record will start. Yes. Okay. So now, if the maximum bending moment, obviously to know, in order to know the maximum the stress, the bending stress coming in the body at a point inside the body which is subject to unsymmetrical bending, then we have to know the maximum bending moment value. So let us consider this maximum bending moment value M. It depends on the loading pattern as well as the type of load, UDL, UVL, point load, or support conditions. So based on this, bending moment, let us consider this bending moment. Maximum bending moment is applying at the axis YY. Okay, so it is vertically. So the load is vertical. The load is transverse. So due to the vertical loading, let us consider the bending moment is coming in this direction. So now this bending moment will be converted. We'll have two components. That is m sine theta. If you see that theta is the angle of inclination, so bending moment is converted into m sine theta and m cos theta. M sine theta in the UU axis and m cos theta in the VV axis. Okay. And let us see the point P is, let us take point P is an interior point or any arbitrary point located within the body. Okay. Now, what is so what is the problem? The problem, why we are taking the point in the body, sir? Because this point, let us take any point, we will be asked to calculate the bending stress or deflection at any location of a point in the body. So let us take any point P having coordinates u and v. Now x coordinate have turned into u and y coordinate have turned into v. So there is a transformation factor which I will write in the whiteboard. Okay. So now if it had been symmetrical bending, then the coordinates of point would have been x and y. But since it has converted into u and y v axis, so it will be P coordinate point P, coordinates u and v. Okay. Now we are interested to find out what is the bending stress within this body. What is the bending stress within this point P? Okay. And see here angle alpha. If someone tells us to find out the location, of neutral axis, this is the neutral axis NA. To find out the location of neutral axis, we need to know this angle alpha, which is inclined with the axis UU. Okay. So here, if you see here, we have written all the details what I told, that the moment in the plane UU, m sine theta, and the moment in the plane VB is m cos theta. Now we have to take these two components and the resulting bending stress in the point P, that is U comma V, is sigma B. Sigma B is the bending stress at any point, which is equals to U into m sine theta by IVV plus V cos theta by IUU. Please make this, we can write this equation, very important, that the bending stress, in order to calculate the bending stress at any arbitrary point having coordinate U and V, then the bending stress is, we will keep the m moment common because the m is a common factor. So m outside. So if you take the m common, m multiplied with u sine theta by IVV plus v cos theta by IUU. Okay. So this is how we can calculate the bending stress at any location of a point in a beam. So in the question, we will be given different points at different location, and we have to find out the bending stress. Okay. Now, someone, if it is asked to find out the location of neutral axis, then tan alpha will be minus of IUU by IVV into tan theta. Tan alpha equals to, alpha is the, you have already seen, alpha is the angle between the neutral axis and UU axis, and theta is the angle of inclination of UU and VV. So we have to know tan theta first. If we know tan theta, then we can find out tan alpha. Okay, so this is also important equation. Then we have to find out the location of neutral axis. Okay. Now coming to, this is the problem we already studied. Now, so first thing, basic thing, that is calculation of principal moment of inertia, all those things. Second is calculating the bending stresses in the point. The second important thing which will be asked in the question, I told. And third thing is deflection of beam due to unsymmetrical bending. That means at any arbitrary point, if someone tells us to find out the deflection, moment is there, bending stress is there. Now, obviously, due to bending moment, there will be deflection also. So that is why if we are asked to calculate the deflection at a point in the body. Okay. So let us consider. So let W is a vertical loading. W can be point load. W can be UDL. Any form of loading can be W. So if W is acting in the YY direction, so if we have the angle theta inclination, so W load, the load W is divided in two components. Along UU axis we have W sin theta, and along VV axis we have W cos theta. Okay. Now see here. So due to so we have deflection. If this was symmetrical bending, then there will be vertical deflection for this body. So vertical deflection for this body meaning deflection along YY axis, but here it is unsymmetrical bending. So we will have deflection along UU and VV axis. Now let us consider. So here we are having, so the load W sin theta is getting applied along axis UU. So therefore we will have a deflection along UU axis, which is represented by delta U. You see, these are all diagrammatical parts. That is why I am showing in the PPT. So the load W sin theta, the load component W sin theta is acting along UU axis, which is causing a deflection delta U. Okay, and along VV axis we have load W cos theta, which is causing a deflection delta V. So due to W sin theta, we will having a deflection, that is delta U, and due to W cos theta, we are having a deflection delta V, which is acting in V direction. So we will take the resultant of these two. We will take the resultant of these two, that is delta. Okay. So we have to know the formula of delta U and delta V, and we can find out the resultant deflection delta. Okay. So now, so let us see here. These things I told you here. Here the words. So W sin theta, you can see W sin theta is along the distance along UG. So UG is U axis and G. G is the centroid. Always remember, in unsymmetrical bending or symmetrical bending, all the four mutually perpendicular axes, they meet at one point, that is CG. If the CG, why people are leaving sometimes, I don't know. Many people are leaving. I can see is getting notified. So I don't know why you are leaving. Anyways, so all these axes, XX, YY, UU, and VV axis, they will be meeting at one point, that is the CG or center of gravity. Now, whether the bending is symmetrical or unsymmetrical, it does not matter. The CG should be same. The location of CG should be same. If the location of CG is altered, or if the location of CG is deviated, it will obviously, the stability of the structure will be diminished or destroyed. Okay, so that is why the meeting point of all the axes is at G. So here I talked about, so W sin theta is along UG, and W cos theta is along VG. Okay, so these are the two load components. And so here finally we can, so delta V here, see delta U, deflection caused by the component W sin theta along the line GU for its bending about VV axis, and delta V is the deflection caused by the component W cos theta. Okay, and finally the formula for delta U, KW sin theta L cube by EIV. KW sin theta L cube by EIV. If you know, that is in deflection, if you remember the chapter slope deflection from strength of materials or if you learn structure analysis 1, there is a chapter was that is slope and deflection. So we learned the slope deflection for determinate structures like simple supported beam, cantilever, using various methods. In those cases, in those determinate structures, the deflection, the formula of deflection was something like some factor is there. For example, we have simple supported beam under UDL. So the deflection will be 5 by 384 WL cube by EI. So the WL cube by EI, if you see, so for any deflection, here we are talking about determinate structure. We are not interested in indeterminate. So delta is, if you remember, there is one value. It may be 1 by 3, it may be 5 by 384, anything. Delta some value divided by this factor will always be there, WL cube by EI. WL cube by EI. Okay. So this WL cube by EI is also there. So here we have a constant, that is K, is coming due to this unsymmetrical bending. So Kw sin theta L cube by EI VV, and delta V Kw cos theta L cube by EI UU, where K is a constant. If you see, K is a constant depending on the end condition of the beam and the position of the load along the beam. Okay, delta U and delta V. So the K value for cantilever it is different. For UDL, for simple support it will be different. Okay. So now we have to remember the final resultant deflection formula. The total or resultant deflection delta is, this is the equation, KWL cube by E whole under square root sin theta by IV whole square plus cos theta by IU whole square. So this is the equation to find out the deflection, the total deflection occurring, the resultant deflection. So KWL cube, where K is a constant value, W, so this part is obviously constant, KWL cube by E whole root of sin theta by IVP whole square plus cos theta by IU whole square. Now another important point, if someone asks the inclination beta of the deflection, what is the inclination angle or the deflection, inclination of deflection with the line GU? Okay. So the inclination angle beta of the deflection, that means in which axis it will deflect. So the deflection axis, the final resulting deflection axis is beta with respect to GU. See here. Let me remove all this diagram. So see here. So this is beta. Okay. This is beta. So now tan beta is also equals to IU by IVV tan. So there are three different equations or three different the location for finding out the angles. One is tan theta, which tan theta, which represents the angle of inclination of XX with UU. Then tan theta, tan alpha, and tan beta. Okay, tan theta and tan beta. Okay, so we have to remember this resultant equation, deflection, this equation to find out the deflection at various points. Okay, if you see this deflection, it depends on the load W. It depends on the angle of inclination, sin theta and cos theta. Okay, so always remember one thing, one trick is there. How to remember this, sir? See, with sin theta it comes IVV, and with cos theta it comes IUU. Sin theta by IVV whole square plus cos theta by IUU whole square. Okay. Now let's see here in the formula for stresses. These stresses also see here, sin theta by IVV here, sin theta by IVV plus m cos theta by IUU into V. Okay. So this we have to find out. Now we will come to the problems where there is a T section, there will be angle section, and at different points we have to find out the various stresses as well as deflection at various points in a body. Okay, the points will be obviously will be shown. So this formula, bending stress, and we have to remember the deflection. The resultant deflection is formula delta. Okay. Now we will come to this problem. It's a very good problem. This type of question you will come. So please take this down. So all of you take this down. After you have copied, you have to copy this diagram also. Okay. So please take it down. An 80 mm by 80 mm angle section is given. Take down this. So take down this numerical first. 80 mm by 80 mm and 10 mm angle section is considered. It is used as simply supported beam of span 2.4 meters or span 2.4 meters. It carries a load of 400 Newton along the line YG. So take all these statements. The question they have asked, that is stresses at point A, B, C, deflection of beam at midsection, and position of neutral axis. So all the first write down the question. Then in the next slide, we have the diagram. So all of you have copied this question. Next, I will forward to the diagram.
Done, sir.
Done? Okay. So now I'm sharing the diagram. So this is the diagram. So properly the diagram is given. We have the equal angle section, 80 mm length, 80 mm. The both edges are 80 mm and thickness is 10 mm. And the angle of inclination is already given 45 degree. The angle of inclination of UU axis and is 45 degree with respect to, and we have two bodies, body 1 and body 2 is also represented here. So here we have to, particularly we have to find out everything. Maybe this may be a question of about 6 to 8 marks, where everything will be asked. Okay. Maybe this question might come of 8 marks. Okay. So I think so here we have two very interestingly see we have two CGs. The point of CG is given G1 and G2. The location is given, and if you see these x axis and y axis, they are meeting at the point G. G is the CG, and we will consider the center of gravity CG. The coordinates are 0, 0. Okay. So with respect to that, we have to find out the coordinates here. The coordinates of CG, that is G1 and G2, for the bodies, that is for G1 it is body 1, and for G2 it is for body 2. Okay. So G1 and G2, these are two CGs, and we have to calculate their location. Obviously, very important. Location is not given. We have to find it out. Okay. And along that, if you see, there are three different points are there, which they have told already. If you see in this question, they have told to find out stresses at point A, B, C, deflection of point at midsection, and position of neutral axis. So this is the leftmost top corner is point A. This point is point A. Can you see the point? Am I marking here? You have to respond with me. No one should keep silent in the class. It is respond.
Yes, sir.
Yes, sir.
Yes, sir. Definitely.
Yes, sir.
The point is left top corner is point A. This point is point B. The left bottom corner point B, and this point is point C. So you have to be very much careful to locate where the points are given. If the points are not given properly, then you will not be able to understand, sir, where to find out. Okay, because these concepts, everything is related with graph paper. If you just imagine you are drawing this diagram in a graph paper, with respect to that, you have to find out the coordinates. Okay, so quickly take down this diagram, then I will come to the question. Done. I think quickly do it. I think you have done. So let us switch off the diagram. Okay. So this is the diagram. So I hope you can see the whiteboard. Okay. So now we have to find out. So first, the same thing, same old story. We have to repeat the same thing. So here we have this angle section, equal angle section. So here we have given. So here equal angle section. Equal angle section is there. Okay. So therefore, first we have to find out CXX and CYY. Here the CX is represented y bar. In this diagram particularly, if you see CXX is represented y bar and CYY is x bar. Already I told you last class how to find out CXX, CYY. So let us start. So CXX. So here for equal angle section, we know that CXX and CYY are same, and also moment about IXX, that is moment of inertia. Moment of inertia about IXX, IYY both are same. So let us start CXX. That is A1 x1 plus A2x2 by, or you can take it not A1x1, let us take E1 by 1 plus E2 by 2 by E1 plus E2. Okay. So we have so CXS is C. So what is CXS? CXS is in vertical direction. That is the distance between this G. The centroidal distance with this centroidal distance with respect to x axis. That is the bottom edge. I told you always to calculate the C distance, we have to check from the bottom edge. Okay. So we have first A1 by 1 plus A2 by 2 for this diagram. First body. So first is 80 into 10 into 5 plus this body. So body 1, body 2. Okay. So y1 is the height, centroidal height of the individual body. So area 80 into 10 into 5 plus this is 80 minus 10, 70 remaining. 70 into 10 multiplied with 70 by 2 plus 10. Whole divided by 800 plus 700. CXX. The CXX will be coming 23.6. The CXX, the centroidal distance on the vertical direction is coming 23.66. Please make sure whatever distances you are calculating, that will be vertical for CXX. Similarly, CYY is same. So therefore, CYY equals to CXX will be 23.66 m. So this distance is 23.66 and this distance is 23.6. And this is origin 0, 0. We have to make sure in order to find out the locations of all these points G1, G2, G2 they have given A, B, C. We have to compute the location with respect to this origin, that is 0, 0. Okay. So CXX, CYY we have found out. Next is this is the step 1. This was step 1. Step 2. Step 1, then step 2. So for step 2, we have to find out the moment of inertia. We have to find out the moment of inertia. Okay. So IXX, let us find one moment of inertia, then we will be able to find out. So here, moment of inertia for equal angle section, I already wrote IXX will be equals to IYY. Let us find out moment of inertia using parallel axis theorem. So let us take for moment of inertia of body 1 plus moment of inertia of body 2, because there are two bodies. Okay. So let us talk about the first thing. First one is this body. So BD cube by 12, so rectangular. So I am talking about IXX. So BD cube, B is 80, D is 10. So BD cube by 12 plus area 800 into this height distance. So the distance between these two TGs, x bar square. So our main formula is what? BD cube by 12 plus A into this one, you can take A into y bar square. Okay, A into y bar square. Or no problem, you can no problem. Okay. So this y bar square is nothing but the distance between CG of the whole body and this body. Okay. So 18 10 cube by 12 plus area area 800 into y bar is the distance between this CG and this body CG. So the total body CG is 23.66 minus the body, this body. Okay. BD cube by 12 plus area into this one. This is the CG of the total body minus the CG of the body 1 distance plus for body 2 BD cube by 12. So B into D cube by 12 BD cube by 12. So B into D cube by 12 plus this area, this is 700 into y bar square. So y bar is 45 minus 23.66 whole square. Okay. From here, if you calculate the IXX, so this is the moment of inertia of about XX axis for body 1. This is the moment of inertia along XS axis for body 2. Okay. Always remember we will calculate the CG from the bottom. From the bottom. Okay. From the bottom. So the moment of inertia is coming around 889. So 8898 C3 minute. Okay. The moment of inertia. This is will be also equals to same IYY because of equality axis. If it is not equal angle, then you have to calculate separately IXX and IYY. Okay. Equal angle section. Equal angle section. Okay. So this is the step 2, that is we have calculated moment of inertia. So now after this we will calculate this location. Next we will calculate. So this is the step 3. Now another step is there. New step, that is we have to find out the coordinates of G1 and G2. In previous question, if you remember, these coordinates were given. Previously, if you remember in previous question, the coordinates of the CG were given. Okay. Now we have to change it because we have to find out. So write down. You can find out. Locate. Now find out determination. Under step 2 only you can write down. Determine location. Determine location of G1, X1, Y1 and G2, X2, Y2. Okay. To determine the location of G1, X1, Y1 and G2, X2, Y2. Obviously, with respect to this, we are calculating with respect to the centroid of the CG of the whole body. We are determining this location of G1 and G2 with respect to the CG of the whole body having the origin 0, 0. Okay. So therefore, backward. So 0, 0. Okay. So now, therefore, so G1, see. So G1 will take X1, Y1. Okay. First coordinate X1, Y. So what will be the location of X1? See here. So you can write like this. G1, X1, Y. So first of all, we are, so see, this point is G. Okay. Now we are going to calculate the location of G1 and G2 with respect to this G. So we have 4 coordinates: first, second, third, and fourth. If this is the graph paper, G is the origin, first, second, third, fourth. Four quadrants. First quadrant, X positive, Y positive, right? Second quadrant, X negative, Y positive. Third quadrant, X negative, Y positive. And fourth quadrant, X positive, Y negative, right? So the coordinates of G1 will be X will be negative and Y will be negative. Okay. So if I find out, so X1 will be minus of how much? See, X1 will be negative, Y1 will be positive. Sorry, X1 will be positive. Sorry. Okay. The fourth quadrant, na, see, if you see the diagram properly, if you see this diagram, G1 is in fourth quadrant. So finding this location also is very important. Okay. The location of this point is very important. G1, G2. So G1, X is positive. So see here. What is the full? So G1 we have to locate. What is the CG? What is the CG from this axis? 23.67 from this side. And what is the CG of this body? 80 by 2. So 80 by 2 is more. So this body, this base is 80 mm. So CG 80 by 2 minus CXX. This will be the location of X1. Similarly, if you talk about y1 minus, so y1 will be what? Y1 will be 23.66 minus 10 by 2. See how we are finding out. I told you we are finding out with respect to origin G. So x-axis, so G1 x-axis what will be? This base is how much? 80 mm. So 80 by 2 is 8 should be 40. Obviously, if this was not there, 8 should have been 40. But here c-axis is also there. So I am finding out this with respect to this point. So 40 minus c-axis, that is the location of G1. Okay, so we are calculating this distance with this dotted line. Okay, these dotted lines, dotted x-axis and y-axis. Similarly, for y1, y1 is in down negative side, so minus this distance. How much? This distance c by c-axis, that is 23.66, 23.66 minus 10 by 2 this distance. So I want to find out this gap, right? This gap. So this total gap minus this gap, that is G1. So the coordinates of G1 is, the coordinates of G1 is 16.34, x1 is 16.34, y1 is minus 18.6. समझ में आया कि नहीं? If you are not able to understand, you can ask me, no problem. There is no hurry, because these are the understanding part, the portion. And if you fail to understand, you will never able to cope up with the problems here.
Sir, in the x1 part, we have to
yes.
subtract minus cxx or cyy.
देखो सी वाई वाई होगा, क्योंकि सी वाई वाई क्यों होगा? क्योंकि देखो ये वाला है सी वाई, ये है सी एक्स एक्स, ये है सी वाई, यहाँ पे सी एक्स एक्स सी वाई वाई सेम हो गया, इसीलिए ऐसे लिख दें. बट इफ इट इज डिफरेंट, मान लो सी एक्स एक्स और सी वाई वाई अनइक्वल एंगल के लिए अलग होगा, हो रहा है, तो क्या माइनस करेंगे? देखो 80 का आधा 40, 40 माइनस ये डिस्टेंस, दैट इज सी वाई वाई. So just make sure it is CYY. Good question. So G1 this. Similarly, we will come for G2. G2 x2 y2. x2 y2 मतलब G2, तो G1 आया समझ में? G2 हो G1 हो गया. नेक्स्ट कम टू G2. G2 कौन सा ये लोकेशन में है? Let me show you the screen. G2 का लोकेशन देखो, सेकेंड क्वाड्रेंट, फर्स्ट सेकेंड थर्ड फोर्थ. सेकेंड क्वाड्रेंट में क्या है? x नेगेटिव y पॉजिटिव, राइट? x आ जाएगा नेगेटिव, y आ जाएगा पॉजिटिव. तो सी, तो देयरफॉर x2 की वजह से नेगेटिव होगा, तो x2 विल बी नेगेटिव. सी, तो व्हाट विल बी द डिस्टेंस ऑफ x2? x2 मतलब यहां से यहां डिस्टेंस, दिस डिस्टेंस है ना? सो इतना, सो सी वाई वाई minus 10 by 2. So we are measuring the distance of G1 from this point, this axis. ये एक्सिस बराबर माप रहा है, तो क्या होगा? 23.66 this total distance minus the half of this bar. So C by y minus 10 by 2 CG, and y2 will be positive. Y2 will be positive. Y2 will be this gap, this height. So how much it will be? Y2 will be
Sir,
a है, बोलो.
sir, upper part get cut, sir. Please move the camera little bit upper, sir.
हाँ हाँ देखो, ठीक है जी. ड्राइंग की हो ना G2, कॉपी में है जरूर, तो वैसे ही होगा. तो G2 का देखो एक डिस्टेंस क्या होगा? दिस डिस्टेंस 23.66, इतना इतना, और यहाँ इसका आधा हटा देंगे, 10 का आधा. सो दिस डिस्टेंस आई हैव टू कैलकुलेट G2, तो वही हुआ माइनस सी वाई वाई माइनस 10 by 2. माइनस बाद आएगा क्योंकि इट एक्सिस नेगेटिव, y पॉजिटिव, y का क्या होगा? देखो y का होगा 70/2 प्लस 10, इतना तो होता ही है। 70 प्लस 2 मतलब 70 का आधा 35 प्लस 10 क्योंकि मिक्सम माप रहा है, प्लस 10 माइनस 23.66। So the coordinate of G2, so therefore the coordinate of G2 is coming minus 18.66 and plus 21.3. Minus 81.66 plus 21.3.
স্যার
হ্যাঁ
স্যার y2 টা আরেকবার বলবেন?
y2 টা দেখো, y2 কোঅর্ডিনেট কি হচ্ছে, সি y2 কোঅর্ডিনেট ইজ নেক্সট টু y2, ঠিক আছে। আর y2 কি করে হলো দেখো, देखो whatever I am calculating distance I will calculating from the bottom, ठीक है। y2 mean be this, y2 mean be this distance, देखो this is basically y2, can you see the board, this is y2, okay। এবার দেখো what is that, this body is 70 mm length, কেন already it is this whole length is 80 but यहाँ पे 10 चला गया तो कितना बचा रहा 70, तो 70/2, 70 का आधा तो हाफ ऑफ 70 32, देखो 70/2 35, 35 right, plus from the below 10 35, 70/2 35 plus 10 minus this distance, obviously because this distance, that is why I will get this distance, na? You have to understand which distance you have to find out, okay। So total, so this body is 70, so 70 is half is 35 plus this distance which I have avoided, this 10, because I am calculating from the base. Why I am calculating from the base, because this distance I know, this distance that is 23.68 is from the base, okay। So this 70/2 because it is CG for this rectangular body, 35 plus 10 minus this distance, then we can find out y2. So 21.34 minus 18.66 and 21.3, এটা যদি না বুঝতে পারো আমি ভালো করে দেখবে, না পারলে তারপর আমার দিও। So after finding out G1 and G2, we have to find out the product of moment of inertia, IX, product of moment of inertia, product of moment of inertia. What is product of moment of inertia? I already told you a1 x1 y1 plus a2 x2 y2, a1 x1 y1 plus a2 x2 y2. a1 x1 y1 plus a2 x2 y2. So therefore put this a1 x1 all these values. So 800 into x1 is 16.34 into minus 18.66 plus a2 x2. You have to take the sign also. You have to take the sign also. So a1 x1 y1, so x1 y1 we need this coordinate x1 y1, so that is why I found out x1 y1 and x2 y2. So the answer is coming like minus 5.226 into 10 to the power 5 mm to the power 4. I always tell that the unit of moment of inertia should be millimeter to the power 4. This is my step 1. So I have got the principal moment Ixx, Iyy, then Ixy. This is very important. or because all these parameters will be required to find out the next items. So now I have to find out IUU and IVV. Okay. So to find out IUU and IVV, I will require IXX, I will require IYY, and I will require IXY. That is what I found out. So now find out. You found out any you find out anyone IUU or IVV. So you can find out the other. So let us find out. Now you can come step 3. Step 3. So what will be the formula of IVV? IVV we know IXX plus IYY by 2. You can find out anything. You can find out IUU. You can find out IVV. No problem. IVV IXX plus IYY by 2 plus into power of IYY minus IXX by 2 whole square plus IXY square. This you put these values, you will get the answer about is coming 14.125 into 10 to the power 5 mm to the power 4. 14.125 into 10 to the power 4 mm to the power 4. Okay. You can find anything. You can find IUU or IVV. So if you are interested to find out IUU, then you have to have minus. This becomes minus. Okay. So after finding out this one principal axis, you can find out using this trick. IUU plus IVV is equals to IXX plus IYY. Simple. So from here you can find out IUU. So therefore IUU is becoming 3.67 into 10 to the power 5 millimeter to the power 4. So step 3, we found out this new principal axis. Now we will come to step 4. Now these are all the things which we have learned previously in previous class. Now after this, what I will do, that is the new for this class. Okay. Now we have to find out the bending stress. Also we have to find out the deflection. So step 4. Step 4. Step 4 will be calculation of bending stress. Calculation of bending stress at points A, B, C. At points A, B, C. As given in the question, we have to find out the bending stresses at point A, B, C. Today only, by today evening, I will mail you this video, the recording of this video and the recording of day 1 video. Okay.
Thank you, sir.
Calculation of bending stress. So now we have to calculate sigma B. Now what is the formula for sigma at any point? Already we know that at any point, let us consider u comma v, the bending stress is m. We take the moment common, m u sin theta by IVV plus v cos theta by IUU, right? M into u sin theta by IVV plus v cos theta by IUU. So now here we have to require the coordinates of u and v. First we'll find out the bending moment. First we'll find out the calculation of maximum bending moment. देखो जो स्टेप वाइज करोगे मार्क्स मिल जाएगा आराम से. You can easily remember. If you remember the step wise na, these big problems will be very easy to understand. In any subject you follow, no problem. If you divide this into step wise, it will be extremely helpful for you only. So maximum bending moment, here we have the point load. देखो, here it is, so we have point load of 400 Newton vertically, okay? So it is something like this. If you consider this the three-dimensional body, just coming, so obviously this is the L section, cross section, so angle section. So if you consider the three-dimensional body, है ना? So this is the beam, the total beam, and this is the length. The length is how much? The length is 2.4 meter. The length is 2.4 meter, and the load is coming like this. T. The load is coming like this. So this is x axis, x, and this is y. This is y. Okay. So now, so this is actually practically how the load is coming on this beam. This you have to understand as a civil engineer. Okay. Or else it is very difficult for you to understand. So now, what is the maximum bending moment? Here it is simply supported beam. Obviously, it is given simply supported beam. So here it is supported. So we have the point load at midspan. So simply supported beam. Want to make you understand that I am getting now. Simply supported beam at midpoint. Simply supported beam at midpoint of span. Simply supported beam midpoint at span. Okay. So what will be the maximum bending moment? Anyone please tell me. If there is midpoint load, point load at midspan of simply supported beam, what will be its maximum bending moment? Very simple. These standard formulas you have to
WL by
remember.
4.
WL by 4. Yeah. WL by 4. So here the load is in newtons. So 400. So this is basically 400 into length. WL by 4. So length will be, I am converting this into millimeters because our Young's modulus is given in Newton millimeter. Okay. So 400 into 2.4. কোনটা কিলোনিউটন দেওয়া আছে? Load is given in Newton. 400 Newton. So 400 into 2.4 into 3 whole divided by 4. That will be equals to 2.4 into, so you just 100 2.4 into 5 Newton millimeter. 2.4 into 5 Newton millimeter. So I have got the maximum moment. This will be equals to m. M which I showed you here. This m is the maximum moment. Understood? So now, so therefore, m is the maximum moment. Now this thing I have got. Okay. So I know the angle theta. Angle theta is 45 degree. So therefore you can put sin 45 is 1 by root 2. Okay. And cos 45 is 1 by root 2. Both are same. So sin 45 1 by root 2, cos 45 1 by root 2. Okay. So I have got all these things. Only the u and v coordinates are left. So therefore, find out the location of points A, B, and C. Location of points A, B, and C. So we have to locate the points A, B, and C in terms of XY coordinate as well as U and V coordinates. So obviously they have told me now to find out the bending space at A, B, and C. तीनों corner में you have to find out, right? So therefore, first you tell me the coordinates of A with respect to X and Y. A with respect to X and Y, B X and Y, and C X and Y. The coordinates of all these. First, we have to find out the coordinates in terms of X and Y axis. Then only after we can go to U and V. So let me share, change the screen. Yes. So this point is A, this point is B, and this point, the right bottom corner is C. The left top corner A, X and Y. So what will be X? X will be this gap. So A is in which coordinate? You tell me. Anyone? A is in which coordinate? Second. So X is negative, Y positive. So X will be minus 23.66 and Y is this one. So Y you can just take the height. Same thing. 7, so 80 minus this thing. 80 minus 23.66. This height 56.34. How it is coming? 80 minus 23.66. So this is the coordinate of A in terms of X and Y. Have you all understood? हाँ या ना? कुछ तो बताओ.
Yes, sir.
Okay, thank you. Next point B. So A point I have got. Next point B. What is the quadrant of B? It is in which
Sir,
quadrant?
minus 23.66 minus 23.66.
Very good. Shabash. Minus 23.66 minus 23.66. Here X and Y coordinate both are negative. Okay. Next point C. Fourth quadrant. Sorry. Yes. Fourth quadrant. C X positive, Y negative. So 23.66 and minus 23.66. So I have got X and Y coordinate in terms of this. Now after getting X and Y, I have to find out U and V. U and V. Okay. So A U and V, B U and V, and C U and V. Do remember, please make it a box. That is the axis transformation. Transformation of axis. This we have learnt in class 11 and 12 while studying vectors. Transformation of axis. So if this X and Y is converted to U and V, then the coordinates of U will become X cos theta minus Y sin theta. Make it a box. X cos theta minus Y plus Y sin theta. Sorry. X cos theta plus Y sin theta. View will be Y cos theta minus X sin X cos Y cos theta minus X sin theta. So this is the transformation of U and Y coordinate, U and V coordinate with respect to X and Y. X will be X cos theta plus Y sin theta, and V will be Y cos theta minus X sin. And we know cos theta sin theta is 1 by root 2, 1 by root 2. You just find out the coordinates of U and V, ABC. Slowly and slowly.
স্যার
হ্যাঁ
আমরা যে সি পয়েন্টটা বার করলাম 23.66, তো সি পয়েন্ট 23.66 তো আমরা ওই দিকটা কি ছিল, তো এই দিকটা
Oh, acha, sorry. Correct. Good. Absolutely good. Acha, y will be actually y will be 20% ঠিক আছে x টা হবে এইটা x will be 56.32.
Yes, sir. 80.
So x will be 80 yeah 80 minus yes. So x will be 56, right? 56.3. 80 minus 23.6, right? Absolutely correct. The coordinate C will be 56.3 because I am calculating it with respect to this this one. This location, so 80, okay? 80 minus this location. So I am calculating all the location with respect to G only. I told you. So this thing. So put the X, U and V and find out for A, B, C.
Sir, A 23.1 and 56.56.
Correct. A is 23.1, 56.5. Next for B,
Sir, for B minus 33.47 and 0.
correct. 33.47 and 0. Next for C,
Sir, 23.10 and 56.57.
23.10 and minus yes, minus 56.5.
Yes, sir.
Minus 56.5. Okay. So these are the three coordinates A, B, C. Why I have taken these U and V coordinates? Because I will apply this in the equation, this equation to find out the stress at point A, stress at point B, stress at point C. Okay. So all of you, please write down these coordinates A, B, C. Then we will apply it to find out the bending stress. So now step okay. So under step 3 only, now we will calculate stress at point A. Okay. So stress at point A. The point A is between now 23.1, 56.56. Okay. So the stress at point A, M, the same formula, U sin theta by IVV plus V cos theta by IUU, right? So just put the values here. The maximum bending moment here, the maximum bending moment we have got is 2.4, 2.4 into 10 to the power 5 plus U 23.1 into 1 by root 2 whole divided by IVV 14.124 into 10 to the power 5 plus so M into u sin theta by IGV plus v cos theta, v cos theta by IUU, that is 3.67 into 10 to the power 5. Find out and tell me the answer slowly. So, by finding out the coordinates of u and v, we will find out the stress at A. So, M we have already calculated maximum bending moment. M into u sin theta, u is 23.1, sin theta 1 by root 2 divided by IGV plus v cos theta by IUU. How much it is coming? Just find it out.
Sir, 28.89.
28.89. It is coming 28.9. It is
স্যার
coming 28. হ্যাঁ বলো।
বলছিলাম যে আপনি যেখানে লিখেছেন না 23.1, ওটা তো মাইনাসে হবে।
23.1 p u a coordinate, yes, it should be a should be yes, obviously a should be minus, just wait, yes, minus 23.1, minus 23.1. So p is minus because if p is in second coordinate, right? So p will be, x will be minus and y will be plus. Just wait a minute. But if you put here, let us find out. Let me put in calculator. All the time.
Sir,
एक minute, just a minute. Let me that here. No, the coordinate of A is coming 23.1 only. By putting in the equation, na, it is coming 23.1 only. Okay. We just putting this in equation. It is coming 23.1 only, not minus. Okay, I've just checked because we have the angle. So it is coming around 28.9 something. like this, 28.9 Newton per millimeter square. Similarly, we will find out stress at B. Stress at B. B point is minus 33.47. B point is minus 33.470. So stress at point B divided by ITB plus 0. So stress at point B is something like this. 2.5 it was 2.4 into 5. Because here the V is 0. The V is 0 we are putting. So here please always all of you please do remember that since the load is vertically, so point A is at the top. So point A is under compression. Point A is under compression, while point B and C, which is the bottom fiber of the beam, they are under tension.
Sir, 4.02.
4.0. Just 4.02. Whatever value is coming, these you put, no problems. This is the method. So point A, point B, and point C. Similarly, find out the stress at C. So the stress at A will be compressive, while the stress at B will be tensile, and C will be also tensile. After this, the last step, step 4, to calculate the deflection. Deflection at midspan. Deflection at midspan. Deflection at midspan. So what is the deflection at midspan? So delta equals to, we all know, the resulting deflection is KWL cube. KWL cube by E whole root over of sin theta by I square plus. How much stress at C is coming? How much stress at C?
Sir,
Same,
minus
same as A.
22.73.
What was your minus?
22.73.
So those who are getting different answers, please cross check at home. That is not a big issue. Okay, it's fine. So the main thing is that we have to put the coordinates properly with the sign, and you get the answer. Okay, no problem. Coming to deflection at midspan, the last thing we have to calculate, that is the deflection. So delta KWL cube by E whole root over of sin theta by I whole square plus cos theta by I whole square. Now what is the value of K? K value, K for simply supported load, K simply supported load with point load, simply supported, SS, okay? I'm writing simply support. K for simply support plus point load. This you have to remember the chart of strength of material book. The slope deflection. K was 1 by 48. If you remember, simply support load under point load, the deflection was like this. Simply supported point load deflection like this. So this deflection was 1 by 48 WLQ by EI. This was like this. Simply supported load for point load. If you consider simply supported load with UDL, then the delta will be 5 by 384. Okay. If it is cantilever beam under point load, then the deflection will be PL cube by CEI. So you have to remember 4 different conditions. Simply supported with point load at mid-span, simply supported with UDL, cantilever with UDL, and cantilever with point. 4 different cases. You just remember the deflection coefficient. So that will be the value of K. K value will not be given in the question. Okay. K value will not be given in the question. So this you have to remember from the slope deflection KB chapter which you have learned in second year. That is in structure analysis 1 or slope strength of materials. Okay. The deflection for simply supported beam under UDL 5 by 384. This is the coefficient. Okay. Similarly, for point load 1 by 48, which we are requiring here, if it is the beam, if the beam is cantilever beam, if it is given, then under point load it will be 1 by 3. So all these things, 4 different cases you have to remember. Point load and cantilever with UDL also that you see from the chart. So put this value of K, E value is this one, 200 into 10 to the power 3 Newton per millimeter square. So put these values, you know K 1 by 48, W will be 400, L cube will be 2.4 into 10 to the power 3, and all these values. Putting these values, you just tell me the answer. E here is given 2 into 10 to the power, E was given in giganewton. Okay. The Young's modulus here it was given. Yes, tell me.
স্যার কেটা হচ্ছে কনস্ট্যান্টটা তো
Eta constant. Eta 1 by 40.
ঠিক আছে
Slowly calculate, and this will be the end of this class.
Hello, sir.
Follow.
Sir, in question, E equal to 200 giganewton, the GN.
Yes, 200 giganewton. Yes. So yes, the deflection is coming around 1.122 mm. You will see the deflection is coming around 1.122 mm. 1.122. 1 kilonewton means how much? 10 to the power 3 Newton. 1 meganewton, 10 to the power 6. Okay, 10 to the minus, sorry. And 1 giganewton, 10 to the power minus 9. Like this. Then you need to find out the location of the neutral axis. That is tan beta. Giganewton. Now, after finding out, you can find out the location of the neutral axis, tan beta. So, location of neutral axis. Location of neutral axis. So, therefore, tan beta equals to IUU by IPV into tan theta minus tan beta equals to IU by IPV tan theta. So from here you will see the beta angle is given. Beta angle is 75.43 degrees with respect to UU axis. With respect to UU axis. Okay? So beta angle, the location of the neutral axis is 70. If you check here, 75.43 degrees. Obviously, I told you with respect to UU axis. So this is tan beta. Okay, so whatever angle you find out, that will be with respect to UU axis beta. This was in the given in our diagram. Okay, so this is the end of the sum. Okay, so take this down.